మ్యూట్ లో ఉండాలి మీరు మాట్లాడాలనుకుంటే. ఒకవేళ వీడియో కావాలంటే ఇప్పుడు వీడియో వస్తుంది, లేదా వీడియో వద్దు అనుకుంటే మళ్ళీ కొట్టాలి.
వీడియో అంటే
అంటే మీరు కనిపిస్తారు అన్నమాట ఆయన.
ఓకే,
మీరు కనిపిస్తున్నారు కదండి ఆయన దాకాలనుకుంటే. లేదు ఒకవేళ
మ్యూట్ వచ్చారా
అంటే మనకు కావాలంటే
కోటరెడ్డి గారు వచ్చారా?
నమస్తే గోపాలకృష్ణ గారు.
Good evening, sir. Good evening to all of you. I am present.
Good evening.
Good evening to all of you.
గుడ్ ఈవినింగ్ సార్ కోటరెడ్డి గారు.
Good evening. Good evening.
I am Narsimhara sir, GMR Polytechnic Yatbaka. Our students and colleagues are attending your meeting, sir.
Yes, yes. Thank you.
Welcome.
Good evening, sir. Kotireddy sir.
Namaste, namaste. Sir.
Namaste, sir. Good evening to all. Okay. Venkateswara garu.
ఏది ఆప్షన్?
మీరు టచ్ చేయండి స్క్రీన్ లో ఒకసారి. ఇప్పుడు వస్తాయి.
మహేష్ రామనందన్
ప్రాడక్ట్ కౌన్సిల్ బోర్డ్ మీటింగ్ చాలా టైం పడుతుంది, గ్రేట్ టైం పడుతుంది యూటర్న్.
సార్
Thank you. వచ్చేసా సార్.
అందరికీ నమస్కారం సార్. కోటిరెడ్డి గారు నమస్తే.
నమస్తే సార్. నమస్తే బ్రహ్మారెడ్డి సార్.
గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్ నాయక్ సార్. గుడ్ ఈవినింగ్ నాయక్ సార్.
నమస్తే నమస్తే
గారు, ఆల్ దోస్ ఆర్ దామోదర్ రెడ్డి గారు, ఇది స్పీకర్ అయిపోయిందా మాట్లాడుతున్నారు? లేదంటే మీరు మీ ప్రాక్టీస్ మీరు అయిన తర్వాత మాట్లాడుతున్నారు. ఇప్పుడు దీని తర్వాత మీరు అయిన తర్వాత మాట్లాడండి సార్. గుడ్ ఈవినింగ్ టు all the honorable participants of this virtual meeting. Today, Engineer Atluri Venkateswara 15th Endowment lecture on recent trends in electrical engineering and adoption in industry by Engineer B. Kotireddy Garu, FI, Scientific Officer, Department of Atomic Energy, Government of India. Respected Speaker Engineer B. Kotireddy Garu, Scientific Officer, Department of Atomic Energy, Dr. G. Venkateswara Garu, Honorary Secretary, Institution of Engineers, India, Telangana State Center, Professor Dr. P. Satish Kumar Garu, FIE, Director, Rajiv Gandhi University of Knowledge Technologies, IIIT, Basra, and convener of this event, past presidents, council members of the Institution of Engineers, India, past chairman, past honorary secretaries, members of Telangana State Center Committee, corporate members of the Institution of Engineers, India, distinguished guests, family members, of Engineer Atluri Venkateswara Garu. Sri Atluri Subbarao Garu, his son, is present here. Representation of media, ladies and gentlemen. Today, I feel it is a great privilege and honor to be amidst this August gathering and extend a warm and hearty welcome to the speaker, the family member and son of Engineer Atluri Venkateswara Garu, and all of you to this 15th endowment lecture of Engineer Atluri Venkateswara Garu. Today, I am very happy to be associated with this memorable event. I would like to say a few words about Telangana State Center. I'm proud to announce that the Telangana State Center is the only and first center out of the 125 centers in the country awarded ISO certification in the history of 102 years of the Institution of Engineers India. And Telangana State Center is one of the most active centers of the Institution of Engineers, which engage successfully the objectives, mission, and vision in translating them into practice. Within its formation of 2 years, it bagged continuously 2 Best State Center awards, and it has been playing very important role in dissemination of information and engineering and contemporary technology, bringing industry, academia, experts, and professionals together on the same platform by regularly conducting and plus organizing international conferences, national conventions, all India seminars, and one-day seminars, workshops, and roundtable conferences, panel discussions throughout the year, almost a program every 3rd or 4th day. I am glad to inform that the Telangana State Center of Institution of Engineers India has been regularly organizing 18 endowment lectures every year on the birthday in the honor of the eminent engineers like V. Subbarao, M. Tirupati Reddy, Dr. J. Purushottam, Engineer Koka Krishna Mohan Rao, Engineer G. V. Subbarao, Engineer T. Hanumantarao, Engineer A. P. Ranganatha Swami, Dr. S. Raghavachari, and Dr. Narla Tatarao, Engineer Matur Gopal Rao, and Engineer Gurram Kodreddy, Atluri Venkateswara Rao, Dr. John A. Murray, Dr. N.V.R.L. and Rao, Engineers L. Venkatakrishna Iyer, K.V. Srinivas Rao, and M.L. Swami, Dr. A. Ramakrishna, and Engineer I. Basavaraju endowment lectures. We wish to inform you that the Telangana State Center is organizing every year in the Sri Venkateswara Atluri Venkateswara Gari endowment lectures on 28th September of the year every year. I am glad to brief about Engineer Atluri Venkateswara Garu, who is a formerly Chief Engineer, AP State Electricity Board and Chairman, Alvain Limited. Engineer Atluri Venkateswara Garu has contributed significantly for the overall development of the state of Andhra Pradesh, and his contribution to the field of electricity and HRD are laudable and memorable. Engineer Atluri Venkateswara Garu served the Andhra Pradesh State Electricity Board for more than 3.5 decades in various capacities and retired as a director personnel. To his credit, the legendary engineer Atluri Venkateswara Rao brought out more than 40 publications in the areas of engineering, HRD, stress management, and personal management, and etc. In addition to publication of several of his articles in leading newspapers across India. Engineer Rao Garu was born on September 28, 1927. In pursuance of the resolution of the then erstwhile AP State Center, so far we have organized 14 endowment lectures since the year 2002 in the memory of this great engineer Atluri Venkateswara garu, and also delivered lectures by persons of high eminence. And today, Telangana State Center arranged Engineer Atluri Venkateswara garu 15th endowment lecture on recent trends in electrical engineering and adoption in industry. Since I know you're all waiting to hear the talk from our eminent speaker, Engineer Kodreddy garu, Scientific Officer, Department of Atomic Energy, I shall limit myself here and hope that you are all really enjoy the technical talk and in the memory of Engineer Atluri Venkateswara. On behalf of the Telangana State Center and on my own behalf, I once again extend a warm and hearty welcome to the Speaker Engineer B. Kodreddy, FIE, Scientific Officer, Department of Atomic Energy, Government of India, and his son Sri Subbarao garu, and all of you to this important event. Thanks, one and all. And now I take the privilege to invite his son, who is here in our office, Sri Subbarao garu, to kindly give his response of him about his father's history. Sir, over to Subbarao, sir.
Good evening, everybody. Good evening, all of members of the Institute of Engineers. I personally thank on behalf of my family members and on my behalf, President Sri Brahma Reddy garu, who is organizing this evening lecture. I also personally thank Kodreddy garu, Scientific Officer, Development Department of Atomic Energy and Government of India. And I thank the office bearers and especially Venkateswara garu, Secretary of the Center. This is 15th annual meeting of my father's endowment lecture, and I'm really grateful to the Institute for organizing the seminar every year, and I thank everybody. Thank you, sir.
Thank you, sir. Thank you, sir. Subbarao, sir. Now, may I request Dr. Professor P. Satish Kumar, Director, Rajiv Gandhi University of Knowledge Technology, IIIT Basra, and convener of this event, then to kindly introduce today's speaker, Professor Engineer B. Kodreddy garu, FI, Scientific Officer, Department of Atomic Energy, Government of India. And over to Professor Satish Kumar garu. Sir, I think Satish Kumar is not there. I request Dr. G. Venkateswara garu, the Honorary Secretary, kindly to introduce today's respected speaker, Engineer B. Kodreddy garu. Over to Dr. G. Venkateswara.
Thank you, sir, Chairman, sir. So it is a pleasure for me to introduce today's speaker, Engineer B. Kodreddy garu. Coming to educational qualifications of Kodreddy garu, he completed diploma in electrical engineering in the year 1983 and AMIE section A and B from Institution of Engineers in the year 1990. Then MBA from Dr. B.R. Ambedkar Open University in the year 1997. Coming to the job profile, joined as a scientific assistant in Department of Atomic Energy in the year 1987. Then promoted to Scientific Officer B in the year 1991 with AMIE qualification, and at present he is the Scientific Officer G. Presently working as Deputy Maintenance Manager Electrical at the Heavy Water Plant Manugur in Bhadradri, Kottagudem district. Coming to memberships in the professional bodies. Actually, he's having 35 years of experience in installation, commissioning, testing, operation, and maintenance of HT and LT substations, machines, batteries, VFDs, electrical vehicles, 12 megawatt grid connected solar power plant. Working with electrical software tools such as ETAP, MATLAB, Homer Pro, and PV systems. Internal auditor for ISO 9001 and also 14001. He has memberships in Institution of Engineers, that is FIE, and IEEE, and also life member of Indian Society for Technical Education. Roles played are commissioning and project engineer, maintenance engineer, protective relay engineer, recruiter, that is the interviews committee member for many posts, in-house trainer, project guide for engineering students, both UG and PG, resource person for faculty development programs. Coming to publications and journal reviewers, he has published 14 papers in international journals. He also published 4 book chapters, published on energy efficiency, safety, machine learning uses, and microgrids, printed by Willy and elsewhere publications. One reference book titled Filed Guide on Electrical Equipment in the year 2021 by Willy Publishers. Reviewer for IEEE Access, SCI Journal, Willy's International Transactions on Electrical Engineering Systems, and IGI Global International Journal of Decision Support System Technology. And coming to areas of interest of our Kotireddy Garu, electrical power systems, renewable energy like solar PV, microgrids, smart grids, and distributed generators, electrical vehicles, condition-based maintenance of equipment, real-time monitoring of electrical systems, deregulated electricity markets, safety and energy audits, arc flash studies. So with this, I request our speaker, Engineer B. Kotireddy Garu, to address the gathering with his lecture with the interesting topic. Sir, kindly. Sir Kotireddy, sir.
Thank you, sir. Dr. Venkateswara garu, thanks for inviting me in short span and giving me the opportunity to speak in front of so many legendaries in electrical engineering. By seeing the faces and people, I do not know what to talk. Right from first generation to I am seeing 4th generation, maybe I may be in 3rd generation. Once again, thanks to our Brahma Reddy sir, the chairman, Venkateswara garu, honorary secretary, the senior most Ramadacharya garu and other members. And also I have invited some students from GMR, Government Model Residential Polytechnic Bhadrachalam, IIT Hyderabad students to join this so that they will be knowing things, what is going on. Senior most people of age of 70 plus, 80 plus also participating in meetings. Of course, since I am far away from Hyderabad, I could not able to join. But once I presented a paper in 34th Engineering Congress, Hyderabad, and also a chairperson for one of the technical session in our institution, Khairatabad Center. So I am at remote place. I could not able to attend. First of all, thanks to the Institution of Engineers, because of which I could able to complete my graduation in electrical engineering and got promoted to the post of scientific officer in the prestigious Atomic Energy Department. Coming to today's topic, first of all, our AVR sir, Engineer Atluri Venkateswara garu, a legendary in AP Undivided Andhra State Electricity Board. Also, I heard he has worked in Alvin and his son now Subbarao garu attended here. So, my heartful tributes to AVR sir, and also thanks to all of you for hearing me. Because of short span, I could not able to put much, so I will try to finish in 30 minutes with 30 slides. Yeah. So today's topic is recent trends in electrical engineering and their adoption in industries. 1G, 2G, mostly now the transition period from 4G to 3G to 4G is going on in electrical systems. Maybe 5G, 6G, like our mobile system, this also will continue. What I thought is recent trends in electrical engineering, what is going on outside, and definitely we have to adapt, the need for the adoption and how to adapt them, what are the benefits and what are the challenges that I want to cover. Maybe the seniors, most of you seen the first G, 1G, 2G, and some of you have seen 3G. I have invited students to know what is going on, how these senior most people are adopting the new technologies. Introduction, as we know, now we cannot imagine our life, human life without electricity. Even power failure of 1 minute is not tolerable to present generation. So thanks to the senior people who have made us our life comfortable with the continuous power supply, that too qualitatively. And with the advancement of technology and faster penetration of power electronic devices, computers, the power system has seen a lot of changes since its invention. These changes have improved the system efficiency, increased the share of renewable energy resources, but there are some challenges parallelly, like harmonics and other control issues, and the evolution of distributed generation, microgrids, smart grids, electrical vehicles, flexible AC transmission system, and drives have made the system more complex. Even though they are giving so many benefits, the system is becoming very, very complex because of these developments. And the main issues, one is whenever we are going for the latest automation or digitalization, cyber security is the issue, and optimum power allocation. When we have multiple energy resources, how to use them optimally, reactive power compensation, harmonics and faults, power quality and lack of, and also the main important thing, lack of skilled manpower. Now everybody is switching over to IT, information technology. So I am fearing one fine day we may not get the hardcore electrical, mechanical and civil engineers in the market. I do not know how we are going to cope up with it. And at the same time, there are opportunities of implementing them for a continual improvement. The main slogan of ISO is continual improvement, and it has created a lot of opportunities for business and further improvements and improving the efficiency of the system. We can implement these latest technologies with the help of IT, Internet of Things, IoT, or Industrial Internet of Things, IIoT, artificial intelligence, machine learning, they are available. If just I have given a brief picture, what is going on world scenario, source-wise, right from 2000 to 2021, I have taken from, this is from one of the website, how it is. Even though we are talking, so many things are going on globally, still we are depending on fossil fuels, mostly the coal. Right now, even in 2021, coal is the major resource power. After that, it is gas or hydro, where the renewable share at the bottommost is very, very minimal. Our department, Atomic Energy, also could not able to contribute much because of some other security and safety issues. Yesterday, I have taken from our National Power Portal on 26th, the day before yesterday, September 26th, what was the installed capacity of our country? It is 405 gigawatt, out of which the renewable share is less than 30%, mainly contributed by our solar of 14% and wind power of 10%. This is the share where the real demand on September 26th, even though the installed capacity is 405 gigawatt, all are not in operating stage. On 26th, the demand, the particular demand was 179 gigawatt and the generation was 178, means the surplus, the shortfall is less than 1.3 gigawatt, means everybody got power, whoever connected got the power. So means the India is able to supply and meeting all the demands. However, Government of India has plans of renewable energy of 175 gigawatt by 2022, which as on date, there is a shortfall of 60 gigawatt, mainly solar. Even though solar, the target was 100 gigawatt by the year end, this year end, till date, we have only 59, nothing but 60% only we have. So there is a shortfall of 60%. And wind also, we have not achieved that target in the year 2022 because of various reasons. And this journey from first generation to fourth generation, the stakeholders are like this. There are researchers who are doing continuous research like power electronic device, artificial intelligence, computers, how to keep them in the system, electrical power system. The researchers are doing research continuously. If it is acceptable, they're putting it to policymakers. If policymakers are accepting, the next part goes to regulators. The regulators means the auditors and the codes and standards. If they accept, it goes to a manufacturer, a product will come out, and users are there. Of course, the bottommost, the burden is falling on engineering community, mostly nowadays on electrical engineers, because we have to give power. Failure of 1 minute power, all will abuse electrical engineers only. So we are the people at bottom level, taking all the load of these people. And role players, mainly in this system, generators and producers. Generation or production, transmission and distribution, and finally the consumer. End user is the consumer. Whereas who is influencing this system of special purpose vehicle is student community. The teachers are the faculty, regulators, non-government organizations, and policy makers. They are influencing this, the graph, whatever the diagram I have shown, this is totally influenced by these people. And the influencing factors in adoption of new technologies. The famously told in ISO audits, we used to tell PESEL model, nothing but wherever we want to implement a new technology, say 5G or some artificial intelligence in electrical power system, or digital relaying system in electrical power systems or substations or switchyards. There are so many factors which will influence the decision and whether to implement them or not. PESEL model is nothing but political. Definitely, without political acceptance, without a political assurance, we cannot do anything. And finally, and we will require economical support from them. And socially, social means the public has to accept it. And technology, what technology we are going to use, is it sustainable or not, and environmentally. When we are doing something new, whether it is going to protect or harm the environment, that is also important. And finally, the legal, whether it is codes or standards or other regulations by respect to governments or local bodies. These are the factors which are influencing whether we have to implement a new thing or not. And coming to our electrical engineer, I am just only refreshing most of you know what is there. Of course, there are some fresh students, so I want to tell them what is the responsibility of an electrical engineer at field. At field means where they are working, where they are distributing power, or they are transmitting power or generating power. The job is design, develop, simulate, prototype, and testing of electrical equipment and systems. And compared with all other disciplines, electrical engineering have a special responsibility of its hazards. The comfort, the amount of comfort, how much it is giving. Parallelly, the danger involved with electricity, electric shock, burns, flashovers, or fire accidents happening, taking place daily we are seeing. So the responsibility of electrical engineer is not only to giving power supply qualitatively, continuously, conservation, environmental protection, as well as safety of the human. I have taken one photograph from our Bahubali movie. If we take the grandma at the bottom, the hand which is raised at the bottom is an electrical engineer. Let us sink, let us sacrifice. We have to protect the other fellows by lifting hand like this. The child is being protected. For electrical engineers, the child is nothing but the consumer. So the responsibility is resting on electrical engineers. And also globally, there are so many expectations on electrical engineers, particularly 5 E's. 5 E's: energy harvesting from renewable resources, efficiently operating all the electrical appliances, parallelly environmental protection, and all the equipment shall have smart features like smartphone, and finally economical. It should be economically viable. So these 5 E's are expected globally from electrical engineers. To achieve above goals, these goals, whatever the goals we are talking, we have to adopt new technologies or recent technologies. Without these new technologies, we cannot implement and we cannot achieve these 5 targets. And if you see the first generation to the latest 4th generation, where is electrical engineering? Generation, transmission, distribution, utilization, and protection is the old era. Now, in generation, the renewables are added, whereas in utilization side, we have smart devices and electrical vehicles, which may pump harmonics into the system. And also, there are uses of IoT or other information, Internet of Things are there. Also, there are appliances and computers which requires power supply continuously with limited variations And also definitely they are pumping harmonics into the system, means nothing but they are polluting the electrical grid. And also information technology, intelligent electronic devices, communication systems, they are also there in the system. This is the modern electrical engineering. Now the latest added in place of IoT or GOT is AI and ML, artificial intelligence and machine learning. And the modern power systems are mostly man-made systems. They are of demand forecasting, scheduling, generation planning, renovated transmission and distribution with a suitable communication system. And the present goal is like a computer. I have kept the name of SD-RAM, nothing but sustainability. Whatever the job we are doing, whatever the equipment we are developing, whatever we are using shall be sustainable. And that user should depend on it, dependability, reliability. It should be always available. It should do the job what for it is kept there. The reliability of 100%, it's availability of 100%. And also it should be maintainable. Whenever there is a problem in the system, it should be maintainable. It should not be use and throw type, because again, it leads to cost as well as electronic waste. That shall be the goal. SD-ROM is the goal of any modern electrical engineer. Solution to achieve all those SD-ROM, solution is 3D. Nothing but digitalization. We have everywhere computers, IoT, AI, ML, everything is available now. Deregulation. Power markets are deregulated. This is going on in a slow phase. In India also, some of the cities now like Bombay best. So there are agencies which are going to supply power to the local areas like mobile phone service providers, and decarbonization, which is causing renewable energy, thrust on renewable energy. And need for electrical engineer. If I am worrying, now most of the old people are worrying, if everybody is opting to IT, what will happen to the core sector like electrical, civil and mechanical? If we think there is no electrical engineer, or if we are not modernized, means not adopting the latest technologies. If you take the New York City, the photograph evening hours, whatever taken in one of the street of nuclear, this New York City will become like this. If there is a blackout or power failure or something went wrong, it will become like this. Nobody will tolerate this thing. So we should able to identify the fault in milliseconds or microseconds. We have to restore the power supply. First of all, it should be continuous power supply qualitatively. Otherwise, we have to release the power as early as possible. That shall be the task of modern electrical engineer. If there is no smart electrical engineers, since smart devices are coming into picture, if we electrical engineers are not adopting the new technologies, smart grids or microgrids are prone to cyber attacks, which leads to blackouts. Some maybe other problems also may come, safety and security of the country and other issues. So we have to make our grids smart as well as resilient. They should be smart enough, but resilient. So we need smart electrical engineers or electrical engineering with the latest technologies. And the electrical engineer, I have given a photograph. The electrical engineer, the modern electrical engineer with the latest technologies in his hand will be appearing like this, as shown in the photograph. And coming to the recent trend and challenges, generation side, we have renewable energy, which is time weather dependent. There is an intermittency. And distributed generation, locally people are generating on their own power electronic devices. Harmonic control is the biggest issue because of these power electronic devices and renewables. Synchronization also a big issue because of the distributed generation. Locally, distribution is going on. Synchronization also a big problem. Transmission and distribution, flexible AC transmission, HVDC, now HVDC of 800 kV is going on. EHVAC of 765 kV is going on now. Distributed generation. And there are problems of laying or installing overhead lines in dense public areas, and also the safety is very, very important. And nowadays, because of DZ, there are two-way metering system. Coming to utilization, increased consumers. Now everybody is having mostly more than 95% of the people have electricity globally. So the consumers are more. Some of them are illiterate. They do not know what is electricity, what are the hazards. The safety is a very, very important for us. Uninterrupted power supply systems, televisions, cell phones, electrical vehicles. These are creating problem to the grid by pumping harmonics into the system. Protection side, because of complex networks, there are chances of maloperation of protective relays. Because of distributed generations in between, the fault current levels are increasing. The accuracy of CT, PTR meters are missing somewhere, and the protection coordination also missing because of these distributed generations which are going on locally. And also switchgear side, the stability and design adequacy. When we are adding some additional generations locally, the fault current level is increasing. The switchgear may not able to withstand. That is also a challenge. The trend is go for new, but the challenge is maintaining the stability of the switchgear is very, very important issue. In addition to above, our generation, transmission, utilization, there are common issues like skilled or industry-ready manpower. Solution: recruit, train, and retrain. And getting training from senior people, most of the senior people are available here like this. We have to utilize their services, get trained, and the responsibility of the owner or employer is retrain and retain them. And preventive maintenance is important. Maintaining the spares and capital requirement for retrofits or renovations also very, very important. And tools and tackles to tackle these challenges and to implement these latest technologies, the solution is ABCD, some certain threats and opportunities. ABCD is the requirement now, not avoid, blame, or confuse. Now it is artificial intelligence, mainly for scheduling and predictions, blockchain technology for trading, particularly deregulated market, cloud computing for enormous amount of data storage, data mining. Of course, ABCD, everything depends on electricity. Without electricity, these equipment will not work. If these things are available, electricity will be efficient. And there are certain threats, cyber attacks, harmonic, synchronization, political, special model, whatever I have told, it is there. Opportunities are like this: smart grids, microgrids, distributed generation, deregulation, wider communication networks, energy conservation. And also to implement these latest technologies, what we require. So I have kept heading of CASIPS. It is nothing but computer aided study in power systems. Everybody is talking about IT or computer, and most of the substations. Recently, I have visited our 400 kV gas insulated substation in Gachibowli. It is a totally online type, completely digitalized 400 kV substation in Gachibowli area. That is gas insulated one. So there we have to utilize the computers so that the system will be more user friendly and within more accurately it will work. Computer aided study in power systems is a must, and power system analysis is to be done regularly because of the renovations, updations, and distributed generation and other loads adding. We have to go for regular study and changing the equipment as well as relay coordination wherever required. We have to adjust. It's nothing but because of integration of renewables, evolution of microgrids, electrical vehicles, and drives. So their optimum power allocation is a must, which is now possible with the help of so many algorithms are available. With the help of machine learning, it is possible. Harmonics, we have to deal with them, and reactive power management is very, very important topic. Earlier, we used to get power bills in terms of kWh. Now it is coming kVAh, means the power factor is taken care there. So we have so many software tools like a PV for designing the solar power plant, whether it is a rooftop or grid mounted. MATLAB Simulink is used for machine learning and artificial intelligence. SK Power Tool for power system analysis. Easy Power, My Power, DigiSilent also same. Home or Energy for optimum allocation of multi-energy resources, and ETAP will take care of everything. And coming to renewable energy resource or non-conventional, harnessing the energy from these Panchabhutas. All of you know the Panchabhutas: the sky, the earth, the fire, the water, and the Vayu. Means where we have opportunity, we have to take the fire. Geothermal, now nearer to my place, the Singareni colliery is going to do experiment of 2 kilowatt geothermal power. They are doing experiments. Geothermal having lot of potential in coming days. Yes, coal, fossil fuel, which you have to conserve now. Air, wind turbines are there, but it is again weather dependent. Water, tidal, we are using. Sky for solar power. So the Panchabhutas, we are using them for getting energy. And coming to our latest trend, UHV transmission is going on. In the year 2000, we have 765 kV is available. Now in India also we have, between Mangur and Warangal, there is Mulugu. There I have seen 765 kV substation of Power Grid Corporation of India. And experiments are being done at 1200 kV globally. 4 or 5 years back, in India also, we have tested, India has tested 1200 kV transmission line of 30 kilometer distance near Agra. Because of some insulator problem, that was stopped. But India also, it is tested for 1200 kV in 2016 or 17. So right now we have 765 kV AC. And solution to adopt a new system, one is go for new thing, or otherwise renovation or retrofit. Existing skeleton retain and retrofit whatever possible, otherwise go for new. When electromagnetic relay, the first generation, replaced with static relay, the second, now we have in digital or numerical relays. Option number 1, straight away remove the old relay, go for the new, which have so many benefits. Like circuit breakers, in place of oil circuit breakers, we can go for vacuum circuit breakers up to 30. Earlier we used to go for GI rod and etc. Coal, sand, yearly once, pour water, take the values. Maintenance cost is very, very high. Now we have chemical earth pits, which we have implemented in our plant recently. Of course, the cost is double, but they are mostly maintenance free. And also coming to the distributed generation, it is nothing but locally, whether it is a solar power or other source of power of wind or anything. Mostly the output will be DC, use inverter, convert into AC, take to point of coupling. Grid is there, loads are there. This is nothing but simple schematic diagram of distributed generation. It can be anything. Only thing, the license is required from the nearest power system operator. Distributed generations are nothing but all these, whether it is a diesel, solar, wind, biomass, hydrogen, we can use it. Coming to smart grid, nowadays everybody is talking the smart grids. Nothing but it is a network which will integrate the actions of all users, generators, consumers. Everybody is connected there for generating and utilizing the electricity efficiently in a sustainable fashion. So here we have generations of whether it is conventional or renewable, it is there and it is transmitted smartly, and grid is monitored with the help of smart metering. There will be energy storage for surplus power and distributed generation, local area or home area networks, and finally it goes to consumer. Everywhere, everything is a smart and smart. Benefits of the smart grids: operational efficiency, energy efficiency, green energy, customer satisfaction. Customer is the guard we have to satisfy. For us, all the electricity consumers are customers for us. And coming to other topic is the microgrid. It is a microgrid, which is nothing but a small grid of, whether it is a AC source or DC source, it is connected to a system where there are loads and different type of supplies. Microgrid, a small area having their own generation, having a connection to the grid. They can form like a gated community in Hyderabad or other cities, gated community, one through roads and other transportation. Here also, they should be self-powered. If surplus, they can export. If deficient, they can import. That is microgrid. And deregulation, if you take the traditional system, vertical lines, generation, transmission, distribution. Top is the generator and the bottom is the consumer. Power is coming from top to bottom and money is flowing from bottom to top. It is only two way. One way, power supply, the other way, money supply. Money flow is going down. Now the latest deregulation system, there will be generations, transmission, distribution, customers, retailers. There are in between, there are system players who will have contracts with generation as well as retail consumers. So here, the power is flowing both the ways and the money is flowing both the ways. Sometimes the customer will become prosumer who will produce power. Say I have a house, rooftop, I can put a solar power, I can generate. If it is surplus, I can export. So even the retailer here have two-way system of power and money. So this is a deregulated market where we can use blockchain technology for its proper implementation and security. And coming to other topic of the latest, electrical vehicles. Now they're slowly picking up. The advantage of everybody knows e-mobility is nothing but sustainable without any gas pipe emissions, tile pipe emissions in cities, and efficiency is more, and it is economical as well as convenience. The latest is the problem with the e-mobility is charging time. So now what people are doing is battery swapping like LPG cylinder, wireless charging, smart charging, and vehicle to grid. Whenever it is surplus, during office hours, keep vehicle outside, let it be charged. Going to house, connect it back, it can be discharged to your house or other areas. So vehicle to grid or grid to vehicle and peer to peer. Two vehicles move parallelly. Whenever we are deficient, other vehicle will give us power wirelessly. That is P2P. That's the latest technology is going on. And adoption. That these technologies can be adopted by optimal design of powertrain. That is the main system where we have battery and motor and controllers, and we can keep fuel cells, which is the latest one, and batteries of not old type of lead acid or nickel cadmium, the lithium ion with the highest energy density and fast charging techniques. People keep, because when the existing fuel filling will not take more than 5 to 10 minutes in petrol pump areas, but electrical vehicles are taking more than 1 hour. Even though fast charging, it is taking more than 1 hour, the consumer will not accept. Though we require fast charging, which should be done within 10 minutes. That is the requirement. And coming to the communication, which is very, very important. We have power line carriers earlier, PLCC, etc. Now we have fiber optics, LAN, WAN, HAN. So many techniques are available now. Also, there is a SCADA, which is used in so many control areas. And coming to other topic, big data. Big data is nothing but people are talking big data. It is nothing but 5 V's: volume, how much data we are getting, because data is a very, very important. Data is a very, very important for improvement or for analysis purpose. It is a must. And variety, what type of data is coming, and how much it is useful value, and what is the velocity, with how much speed it is coming, and veracity, is it consistent or not. Big data is nothing but it is a concept of 5 V's. If the data is coming with all these factors considered, the data is a very, very useful for future developments and further digitalization. And this blockchain technology with the chains and blocks, the information can be categorized locally with the different chains so that the security is maintained, security is ensured. And coming to the next one, artificial intelligence, evolution of AI techniques brought tremendous change in industrial sector, especially in our electrical engineering field, no doubt in that. Particularly forecasting, maintenance practice, optimal allocation of resource, supply demand balance, everything is being done with the help of artificial intelligence techniques. And machine learning finds wider applications in distribution system, voltage regulation, adaptive protection system. Whenever a solar PV plant is generating, the relay settings will be different. When solar power is off, the relay settings are different. Adaptive power protection system is possible with the help of artificial intelligence, and small storage system is possible with the help of AI. And there is one more technique in AI that other than machine learning, we have deep learning. Deep learning can be used for image processing. Let us take thermal camera, what we are using for hotspot finding of generator, motor, or solar PV module. That can be now used with the help of deep learning technique, which will make the life simple and more efficient. And coming to this, deep grid can be used, deep learning can be used in forecasting, power quality monitoring, microgrids, electrical vehicle, miscellaneous. Everywhere deep learning can be used. I have practiced something. It is useful everywhere. And coming to the next one, IoT is available, Internet of Things, with which electrical IoT, distributed generation, microgrid, storage, metering, everything can be monitored with the help of sensors at different places. And the motto of IoT, Internet of Things, is nothing but connection at any time, any place, and anything. Like a cine hero dialogue in one of the movie, any place, any time. Here, we are heroes of giving comfort to the other public. So our motto should be anytime, any place, anything, any amount of power we have to give. That shall be the motto. And coming to the other technique, latest is nothing but arc flash study. If we see in Hyderabad, this is a pharma hub of country, Hyderabad, there are so many drugs or other pharmaceutical exports are going on to particularly to Western countries and USA. US FDA coming yearly once to Hyderabad, and they are inspecting all the pharma industries nowadays. What I heard, they are specifically nowadays asking arc flash study. Whenever something goes wrong with any electrical distribution system or anywhere, what is the arc energy developed, how you are going to protect. The IEEE 1584 of 2018 edition has given guidelines, and National Fire Protection Association 70E of National Electric Code NEC 2020 of USA talks about it. So this is very, very important now required, and lot of job creation is possible with arc flash safety, and it's a study. And maintenance practices, traditional is a scheduled or preventive maintenance of time-based maintenance. Later on change to condition-based maintenance with the help of vibration analysis or thermal camera, find out the performance of any machine, attend it. Now the latest concept is reliability-centered maintenance or no maintenance. It should be zero preventive maintenance. That is what the concept of future. Modular type equipment. Whenever in any equipment there is a problem with small component, replace it. A modular type of equipment is required now. That is going to happen now. And coming to management system, ISO, everybody knows 9001, 14001. There are so many standards they are required to adopt these new technologies. And coming to the future electricity, this is the traditional electricity grid of transmission, distribution, generation, and a consumer. The latest is like this, where we have storage in the form of batteries or compressed air or some new techniques. Electrical vehicles are the new, and coming to other side, renewable energy is a new, and a smart transmission distribution. So the future grid will be like this, and somebody has predicted by 2050, the electrical grid will appear like this as shown right side. And coming to conclusion, the nature of use of electricity is taking many shapes at the end user point. It is changing continuously with regular research and with the help of intelligence devices and IT or IoT. The technology that thought today is becoming obsolete by tomorrow. So the electrical engineering field is spreading all the places with its wide uses and advancements. It is reaching remote places. In this presentation, I have highlighted some of the latest trends in electrical power system and their adoptions. And whenever I used to go for any webinar or topic, I used to tell 10 commandments for any electrical engineer or upcoming electrical engineer, that is students. Let us contribute in getting government's plan of 175 gigawatt by this year end. Presently, the solar PV cell efficiency is around 22 or 23%. It should be more than 30%. Transmit power at 1000 kV DC and 1500 kV AC with the help of FATs. Encourage adoption of smart and microgrids. In getting energy density of 1000 watt hours per kg of lithium batteries. Right now, it is around 300 to 400 watt hour. It should be more than 1000 watt hour. Then only the battery cost will come down. Means electrical vehicles will be more. And towards e-mobility, electrical vehicles, that is FAME 2 of Government of India, to develop harmonic-less drives, to use renewable oils for transformers. In transformers, we are using natural oil, natural resource. It should be replaced with renewable oils like coconut oil or soybean oil. Faster adoption of deregulated electricity market for better competition. Lastly, but not the least, using electricity safely. Thank you, one and all.
Thank you, sir, Engineer Kodreddy Garu.
Thank you, sir.
For an excellent and very informative, practical presentation. And really, sir, it was really a wonderful presentation, right from covering from the old system to the latest technology and blockchain technology, artificial intelligence, and deep learning, how it is used in electrical industry and electrical engineering. And also, we have mentioned about wireless charging and other things, and how renewable energy and what is the status today in India about our power generation and requirement and demand, other things, and UHSV transmission and solutions to adopt new systems, and also cautions and safety guidelines, or rather say, you have mentioned them as the 10 commandments to the electrical engineers, and the challenges to be faced by the future electrical engineers. And wonderful, sir. Thank you for giving us very befitting presentation to the legendary Atluri Venkateswara garu, the engineer of great eminence. Thank you for your presentation, sir. So before I ask others to ask a question, if you permit, I would like to ask a small question, sir.
Yes, sir.
Sir, now everywhere I'm reading in net or coming to know in the other countries, and they're using wireless power transmission. Is it the transmission of the electricity is transmitted from one place to other place, or what is the distance it can travel without any wires? Or anything has come like that in the latest technologies?
Yes, sir. This wireless charging experiments are going on. And I have seen recently 16 kilowatt power is transmitted for a short distance for an electrical vehicle. Whereas some other companies, big companies like ABB has tried up to 1 kilometer distance of 400 volt AC, but the efficiency less than 50%. Whereas in case of electrical vehicle, the recent experiment by one other company, 16 kilowatt from wall mounted charger to the vehicle, a distance of around 10 feet, the efficiency was around 70%. So means the coupling coefficient between these two is very low because of the air in between. So it is a creating problem. It may take some more time, sir, for this wireless charging. The distance between the primary and secondary coil should be less than 500 mm. Then the efficiency will be 90%.
Thank you, sir. But what frequency is it?
Frequency can be 50, 60, or mostly we have to go for higher frequency of 100 or 120 hertz. That will be better. But not kilohertz, sir. Again, there are some problems with this higher.
And also this wireless power transmission actually linked to the generation of magnetic field, because unless there is a magnetic field generated, it can't be transferred from without wire from one place to the other place. That is what the electric current theory says. Of course, your answer was very correct in wireless charging and the frequency part. So, any developments we expect with the development of now new technology coming like artificial intelligence and other thing in future also, even the present distribution system will be converted into a wireless distribution system, so that most of the consumers and the benefited in the house. There is no like wire damage or some rain comes, the power goes, all that. I think the power cuts will be totally eliminated or minimized if the wireless comes. That's what I feel. What is your opinion, sir?
Yes, sir. Definitely it is there, sir. But only thing is, when you are transmitting, one is wirelessly, definitely electromagnetic radiation. Right now, people are talking if it is more than 400 kV, there are chances of electromagnetic radiation. That's why we are putting that pathway gap. We are maintaining 30 feet or 40 feet. Whereas now we have P2P, peer-to-peer vehicle. One vehicle is moving with a fully charged battery. Nearby of gap of 2 meters or 1 meter, other vehicle is battery is getting charged. But cyber attacks are when our house is getting power remotely, wirelessly, without wire, where we can avoid all the problems of short circuit, loose contact at fault. But somebody, if they trap our line, the power will be disturbed and it will be diverted. There is a chance of diversion. So there is a chance, of course, this new techniques of machine learning will definitely give you a solution to that. I hope it will happen in another 5 to 10 years. Definitely it will be possible.
Thank you, sir. Thank you so much. Is anybody wants to ask any question? Kindly, Kodreddy garu. Yeah, Professor G. Radhakrishnan garu, please unmute. You have raised your hand. Please unmute yourself.
Yeah. Thank you, Chairman. Engineer Kodreddy garu, very good explanation you have given, and your slides are also very good. I want to put some 2-3 questions to you. One is this 5-star and 4-star, 3-star they are telling. Really, is it saving the power?
Yes, sir. Definitely. Of course, subject to the environment, the ambient temperature or reference temperature, what they have given. Let us take one air conditioner of 3-star, 4-star, 5-star.
Yeah.
what they are saying is they have tested at 27 degrees centigrade ambient and they are giving the values.
Oh.
That's why now this earlier EER, energy efficiency ratio of old, if you see the old AC example, EER of 3 or 4 is removed now. ISER, Indian Seasonal Energy Efficiency Ratio. Now it should be tested as per the seasons, which season it is working and what is the efficiency ratio. If the equipment is tested as per ISER ratio, Indian Seasonal Energy Efficiency Ratio, definitely it will give its benefit. And in industry, when we are purchasing something, definitely we are verifying, sir, whether it is a BLDC fan motor or a 3-star, 4-star. We are comparing and we are monitoring, sir, definitely. But the caution is wherever there is a smart equipment saving is going on, definitely they are pumping harmonics into the system. No doubt in that. They are polluting our
one question is,
yes, sir.
As per KCR, when he becomes a prime minister, he told that he will give 24 hours power to the nation. How much power is required to have a 24 hours throughout the country of India?
Of course, I am not having that much information, sir, but right now it is a 405 gigawatt, and by 2050, Indian generation projected is 1250 gigawatt. As per our departmental information, 1250 gigawatt. Definitely it is possible because of the entry of private players. It is possible, sir. 1000 gigawatt and above. And I have shown you day before yesterday, the demand was 175 and generation also 175. We have met it, sir. Definitely up to 400 gigawatt right now it is possible.
Okay. The last question is, last question is whether, sorry, I forgot. Okay. Thank you very much.
You can remember, by the time somebody else is ringing. Dr. Ramana.
Some other people, let them talk.
Yes, sir. Naik, sir.
Professor Kodet have a highly appreciable talk, particularly about the 5 E's. And just now, my friend, eminent professor, senior most professor in the world, Professor Radhakrishna Gollagaru, asked a very good question. So it is possible, sir. Not only KCR. KCR promise out of guarantee Batkama Shubhakakshandarku, Uche Batkama Galla, and promise Chaitadu. Kani, I have been to one parliamentary standing question with the Honorable MP Nagan Malashwaga to pair Rensal and Lok Sabha. That meeting, he is told Chinese are developing in a year 10,000 megawatts above more than that. Alarm easy you can reach not only power, even irrigation also. So much of lakhs of TMC unnecessary waste going to the sea. We can throw it India throw it Ganga to Kaveri, amend Dr. Irrigation power rendu kalpi, sir, easily we can achieve, sir. This is not possible. Easy possible. Thank you, sir. Highly good talk. 5 years are good, sir. Happy Batkama all. Thank you.
Thank you.
Gonukuntla Kondalrao garu.
Namaskaram andi.
Oh, Kondal sir, namaste. Thank you.
I am a civil engineer.
Yeah, real civil.
Now there is no civil, electrical, don't define. Without
no, it is a
electrical. Now no engineering, all engineering are one.
Yeah,
yes, right.
All India are one.
Yeah. So my question is, so what is the present status of solar power batteries? Solar batteries, what is the status, technological update?
Please clear, sir. What is solar battery? Means it's a battery only. Whether it is solar or electrical vehicle, it is a battery.
Okay, sir. What is the technological updates? That's what I am asking.
Traditionally, we have lead acid, where the energy density is 200 watt-hour per 1 kg of material what we have used. Then later on, we have gone for nickel cadmium, which is not much. Its losses are more. Then lithium ion. Lithium ion is giving 400 to 600 watt-hours per kg. And now the latest trend is a lithium air battery. Lithium air battery, which can give more than 1200 watt-hours per kg of the material used. The only problem, number one, lithium, the metal is coming from only one country. Most of the material is coming from Congo, where the mines are totally taken by China. Yes, from there it should come to us. So means we are going to depend on somebody else. Lithium, we are depending on external factors. So, but right now, lithium iron phosphate battery is the number one. Now it is going on. but there are problems with the lithium battery. We know the sad incident of last week in Secunderabad, one of the hotel in Secunderabad, we know what happened with the battery only. So the technology is not proven safety point of view. Energy density may be more, but if you take the lead acid battery, even though it is having acids, H2SO4, still it is safe. Lithium ion, we have seen the accident, how it took place last week, and 8 lives in Hyderabad, Secunderabad hotel. People who are sleeping in the room dead. So the new technologies, the lithium is not proven from safety point of view.
Another thing is supply chain problems.
Supply chain problem, yes. Particularly, we are going to depend on one country where they can dictate us.
Okay. So what is the status of what are the safety issues regarding 765 kV transmission lines?
765
Any environmental
kV
issues?
Yes, sir. One is a 765 kV laying of line and the right of the way, what electrical engineer will call the land. We are civil only. The land requirement means when we are laying a line, land is required. And moreover, 765 kV requires a lot of clearance. Nowadays, people are not giving land, and public dense areas, it cannot move. It has to go through forest. Again, trees and other problems are coming. And electromagnetic radiation, which is going to cause, not proven, but people are saying, medical people are saying there is a chance of skin cancer if the voltage is more than 400 kV and we are nearby. That is the problem. So there are some problems with that. Whereas DC with only one conductor at the head, overhead, and one ground as a return conductor is somewhat better. This electromagnetic radiation is less. So we can go for DC. But again, at the generation side, at the distribution side, converters, or electronic devices are required, cost and harmonics. These are the problems.
So now the 765 kV is AC transmission only now.
Yes, it is
Not
proven.
DC.
Not DC. DC we are using 500 kV. Nearer to my area, Sealer also we are using 500 kV, and Mulgu we have 765 kV substation itself, switchyard.
So thank you.
Okay.
Thank you, sir. Anybody else? Okay, thank you, sir, so much for your excellent presentation, and really you covered from, I can say simply A to Z in the electrical engineering, right from the olden days to the present new emerging technologies. Thank you, sir, Kotredi sir. Now it's time for the secretaries of Dr. G. Venkateswara to kindly propose vote of thanks.
Thank you, sir. Chairman, sir. It is my pleasant duty to propose a vote of thanks. Respected Speaker, Engineer B. Kotredi, FIE, Scientific Officer, Department of Atomic Energy, Government of India. Engineer B. Brahmareddy, FIE, Chairman, IEA Telangana State Center. Dr. ISN Raju, Council Member. Engineer M. Santata Reddy, Council Member. Professor Dr. Ramna Nayak, Council Members of IEI, past Chairman and past Honorary Secretaries of IEI Telangana State Center, Members of Telangana State Central Committee, corporate members of IEI, distinguished guests, family members of Engineer Atluri Venkateswara, representatives of media, ladies and gentlemen. On behalf of the Telangana State Center of IEI and on my own behalf, I convey our sincere and profound thanks to the Engineer B. Kotredi Garu, FIE Scientific Officer, Department of Atomic Energy, Government of India, for readily accepting our invitation within a short period. Just yesterday only we requested him to be the speaker. He accepted and gave an excellent lecture on the topic recent trends in electrical engineering. So thank you once again, sir, Dr. Engineer B. Kotredi Garu. I also thank the dignitaries, council members of IEI, past chairman, past honorary secretaries, members of Telangana State Central Committee, corporate members of IEI and others. I also thank the representatives of electronic and print media. Thanks to one and all. Now I request all of you kindly stand for national anthem.
जनगण मन अधिनायक जय हे। भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा, द्राविड उत्कल बंगा, विंध्य हिमाचल यमुना गंगा, उच्चल जलधि तरंगा। तव शुभ नामे जागे, तव शुभ आशीष मागे, गाहे तव जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे, जय 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 हे।
Jai Hind.
Thank you, sir.
Thank
you, sir.
Thank you, Coordinator sir.
Thank you, sir.
Coordinator garu.
Great presentation. Thank you, sir.
Thank you.
Thank you, Coordinator sir.
Thank you.
Namaste.
Sir, Baji per, sir. Congratulations.
Thank you.